Next, we have Andreas. And so he is a founder and CEO of Cognixion. And he is providing, where he's providing the hundreds of millions of people with communication disabilities a way to express their voice. So the company creates natural interfaces powered by AI to facilitate and improve communication. And so in addition to Speakprose, a mobile app that uses gestures and eye tracking to build sentences, the team is developing a wireless BCI with AR integrated. And so I'll pass this over to you.
Hey, thanks, Eden. Appreciate it. Let me pull up some slides here for you guys. Is everybody able to see my screen here? Can I get a thumbs up?
Yep.
Yay, I like the thumbs up. Good, cool. Thank you. So my name's Andreas Forsland. I'm the founder and CEO of Cognixion, formerly known as SmartStones. So we started out as an IoT company back in 2014. If you can see my webcam, I'm holding this little, what looks like a pebble, and it's on this cool piece of walnut inductive charging thing. And it's a totally hermetically sealed little river stone, asymmetric design. And it essentially is a wireless mobile controller. So you could use gestures to interact and control mobile applications. You could also use touch gestures on the stone itself. And so it was really where we all started, was this smart stone. But what we realized is as an accessory, there was a limited market opportunity for what we wanted to do with it. And you can learn more about the background about why I created it, but it was actually my mom got sick with pneumonia and she was intubated in the ICU and she couldn't communicate verbally. So I conceived this concept of a stone that could control an app. So if she were in the bed, she could literally shake it and it would say, you know, call help or do different things that were really primitive translation techniques. But what we did is we took what we learned with the stone and we applied it to a BCI communication interface. So essentially a think to speak interface back in 2016. And so we started out doing research back then and we realized that there was enough potential to fully pivot the company and rebrand it as a neurotechnology company. So you can see here that this, you know, neurotech.com has done a good job of kind of assembling a really comprehensive list of like all the different kinds of companies and organizations that are in the neurotech industry. So I definitely recommend checking out neurotech.com if you're curious about all the different companies that are out there that do different things. So if you know, a certain kind of applied neurotechnology is of interest to you, whether you want to get into brain-computer interface work like what we're doing, or you want to get into neurofeedback or other things, it's a great resource for you to tap into. But there aren't a lot of companies that are in the BCI space relative to the overall neurotech. So you're pretty much talking to a few of them right here on this call. So Joseph, you know, I'm super glad to follow you, you know, and OpenBCI has really been kind of, you know, a real cornerstone for the industry. So I appreciate everything that you guys do and have done. And we're just glad to be here. In the sense that, you know, what we're trying to do is really specific. So we've been looking at the market and saying, well, you know, how many people are affected by communication challenges or disabilities in general? And not a lot of people realize the magnitude in the statistics and the demographics of how many people have a disability. Specifically a disability such as vision, hearing, speech, cognitive disabilities, and motor. There's over 1 billion people worldwide, right? So that's a big number. It's a lot of people. And usually when you think of somebody who has a disability, you forget that they have an entire care circle around them, right? They have families, friends, loved ones, colleagues, just strangers at the coffee shop, You might have a doctor, you might have a team of doctors. And so these individuals aren't just limited by their disability, but there's a whole sort of social impact or a ripple effect. So by providing more independence for an individual that has a disability, you're actually positively affecting the world, right? Through second and third degree impact. But if you look at, that billion people, 500 million are affected by speech. So half of that, and like sort of take that in for a second, right? About 500 million people, which is more than all of Canada, all of the United States, and all of Mexico combined. So the entire North America, imagine if everybody that you knew couldn't talk. Like, how would you actually get anything done? I mean, it's a kind of a heavy topic to think about, but it's an interesting one to imagine the scale. Now, if you think about the people that actually have access to technology that need it for augmentative speech communication, we're talking about less than maybe 2% of the world's population has access to technology. So what we're trying to do is look at the rest of the market that doesn't have access to technology and seeing, is there a scalable way that we can bring a solution that a lot of people could use and personalize for their needs. And we're starting with people with communication disabilities first. So our board of directors includes myself. My background, I started at, a long time ago. My first job was at IBM. And then I worked at Philips. So I worked in Atlanta and then Amsterdam and Sao Paulo. And I worked as a design strategist. So I'm not a neuroscientist by trade, I'm a designer. And so my background is in product design, user experience design. And so I worked at Philips and I worked at Citrix doing software and then started this company. Along the way, we sort of built a motley crew of a team, and Tom Gruber, who's the co-founder and CTO of Siri, which was acquired by Apple. He was the head of advanced AI development at Apple for 8 years. He left Apple and now he's on our board of directors, helping us with language systems and how to use AI to augment a human's capability. And then we have a lead investor. So something to think about is it takes a lot of time and it takes a whole team to do this kind of work. So if you're thinking about building a team or a company, depends on how you want to do it. If you want to bootstrap it, but it would be a good idea to have a funding strategy. Like Joseph was saying, you got to think ahead around how you're going to actually build not just the product, but build the business. We started in Santa Barbara, but then we opened up a team in Toronto. So we have a R&D team downtown Richmond Street in downtown Toronto. And we've got a team of about 10 people there in Toronto, including neuroscientists, engineers, systems architects, et cetera. So I told you a little bit about the size. So the irony is a lot of these disabilities are affected by the CNS. So there's central nervous system and peripheral nervous system disabilities. So your ability to speak sometimes is neurological, sometimes it's actually motor function. It could be the connection between your mind and your muscles and your mouth. And so there's lots of complexity in the ability to generate communication. Same thing with vision and hearing, so you guys are in the right field to make a huge difference in a lot of lives, whether you want to deal with speech or motor or hearing or vision. There's an abundance of opportunities to solve. For us, when we look at people that are affected by speech disabilities, the ones that would benefit the most for us for what we're working on are represented here on this chart. And this is a bit of a roadmap of the types of individuals that we want to work with, but we put priority to the ones on the right, specifically cerebral palsy, ALS, MS, SMA, locked in, tetraplegia, Rett, and Huntington's. Those are kind of the top ones that we work with. Because of, we've got a great depth of clinical knowledge around human factors, around acceptance criteria for someone who could wear a BCI for long periods of time. So we're not building a BCI that could be used, once in a while or in a lab. We're building something that someone could wear for 8 hours a day, every day. And so as a non-invasive BCI and use it for supports of daily active living. So there's a lot of human factors, issues that we have to take great care. Things like weight, battery life, EMI interference, any kind of biocompatibility, dermal conditions, skin conditions. So there's all kinds of stuff that we have to deal with. So I'm kind of trying to move quickly because we're on a compressed time frame, but our tech vision here really is, when you think about all those different disabilities, they're really kind of a magnification of everybody's lives, right? So we're focused on universal design for people who live on the edges or the spectrum. So someone who, like ALS, as an example, you know, they're completely paralyzed in their own body. So they can't move at all. And so the ability to control something without any movement or any direct selection ability is one challenge. And then someone that has cerebral palsy that might be hyperkinetic movement, they might not be able to stop moving. So you have no movement and uncontrollable movement. And how do you create an interface that someone can use that can go across that spectrum? And what that leads to is that you need to be able to have a flexible system that can work as a platform with multiple kinds of inputs and multiple kinds of outputs. And then you're using software to enrich the digital processing of that through context awareness, meta tagging, whether it's streaming the data or you're appending and enriching the data, so that essentially you can take an intention, whether that's a touch intention or a biosignal intention or a keystroke or an eye gaze, as an input, and be able to better understand that intention so that we can shrink the time it takes for them to implement or execute an output. So ultimately what we're trying to create is this universal joint kind of platform that can take just about any kind of input, map it to an output, and reduce the amount of time it takes through sensor fusion. So being able to let different sensors collaborate with each other. So in the case of our headset, we're using, say, you know, the accelerometer in combination with EEG, and that's a collaboration that can work together to give a better idea of someone's intention when they're interacting with an interface. So thinking about this as you're thinking through your own careers or the types of projects you want to work on, oftentimes we specialize in one specific area or another, but really the end user benefits from collaborating, right, cross-functionally. So it's something to think about when you're working on your own projects. For us, we're focused on using evoked potentials as our primary platform for interaction. So if any of you are familiar with SSVEP or code modulated visually evoked potentials or audio evoked potentials, or even in the realm of haptics, our system includes stereo speakers as well as stereo haptics in addition to the display itself. So we can stimulate the brain through essentially your vision, hearing, and somatosensory areas. And we're essentially stimulating it with different kinds of frequencies. We can enrich that data through streaming meta tagging on the analog side, also on the digital side. And as we're doing that, we're closing the loop within the headset so that the system starts to adapt to the user based on certain patterns of use as they're interacting with the AR. So I can get kind of more into this stuff later if you guys have questions. I'm trying to kind of move along here. One of the things we've done is not just work on technology. We've also said, in order for this to be successful, we really need to be close to our customers. So we've established a Brainiac Council of user advisors. So we have close to 100 people now. This slide is old. We've got about 100 people who represent that chart that I showed you. In addition to technical and clinical experts. So we have neurologists in the council, we have speech language pathologists on the council, OTs and PTs on the council, and we also have some individuals who are quite prolific in the accessibility industry. So this gentleman in the middle, Alan Brightman, for some of you who maybe don't recall, too young to recall, that the original Macintosh launch when Steve Jobs in 1984 launched the Mac. Prior to launching that, Alan worked for Steve, and Alan, he convinced Steve, he basically said, before you launch this Macintosh, why don't you sit on your hands and try and figure out how to boot it up without, hands-free. And Steve and his executive team couldn't boot up the Mac hands-free. And that's when Steve recognized the importance of accessibility and built it into the culture at Apple. So a little history lesson for you guys there. So, you know, sometimes it's pretty interesting that we're able to stand on the shoulders of these kinds of giants and still be influenced by the work they do. We've been doing a lot of testing with different individuals in the field in Canada and also in the United States. I have some videos here, but I don't think I have time to show them right now, but we have videos of people using the AR system to communicate, also to control remote prostheses and robots using the headset. Like Eden mentioned in my intro, so we launched an app on iPads and iPhones first to validate the market and to validate the need. So sometimes you might need to verify that you're on the right path with whatever solution you're creating. So we launched an iOS app, and we've got over 70,000 active users on the application right now that are using the speech generating app we've created. And it's created an opportunity for us to nurture those relationships, better understand what they're trying to do, what they'd like to accomplish with augmentative communication. And then also a large percentage of those who are iPad users today are interested in moving over to the headset when it's ready. So we're quite excited about that. Also, we're going to be announcing in February a partnership with an organization that sells into universities worldwide, so that universities and corporate labs can have access to the headset. Also, if you or anyone you know are interested in joining our Brainiac program, it's a highly interactive program. We do monthly Zooms and field work together. For us, our user is our hero. We care deeply about the user and their needs and aspirations. But for us, our go-to-market is to through neurology as a first touch, and usually neurologists recommend speech therapists to then evaluate a user for a speech generating device. So this is really our ecosystem. So we work a lot with developing relationships with speech therapists and neurologists as well as end users. So that's all the non-technical stuff. So let's kind of look at the tech stuff, which is probably what you're here for. This is a breakdown of the headset. I can get kind of into I geek out on all this stuff, but it's a fully integrated system, kind of like you might see with a Microsoft HoloLens, except it's primarily the BCI. We didn't really invest heavily in the AR. What we're doing is building kind of like a Google Cardboard, but we're using a mobile form factor. So we have a mobile phone that's reflected into a tinted but reflected lens on the front. So anyone who can write a Unity app can basically build AR applications for this headset on a mobile platform. And then the BCI itself is EEG. It's fully self-contained. There's 8 channels. 6 of them are dedicated to the visual cortex. So occipital, so O1, O2, OZ, PO3, PO4, POZ. We have 2 auxiliary ports that if you want to run leads out to other parts of the body, you could do so. And all the processing is happening local. So it's totally secure, totally private. The BCI is communicating with the mobile AR over Bluetooth, over BLE, but it also has a serial port, a USB-C out. So if you wanted to run raw data at super high sample rates out the USB to, say, a workstation, you could also do that. But it's really designed to be a totally wireless, totally mobile, long duration wear, essentially an accessibility tool for our clinical use case, but also for you guys in universities. If you'd like to try it out, you're welcome to, give it a shot. Long battery life, I just mentioned about the USB port. Every electrode is individually axially adjustable, so including reference and ground, which are on the sides of the strap for comfort and signal quality. It's got a removable cover on the back, so you can sort of dial in each of your electrodes as you'd like. And you can see that it's got a mobile form factor, so the phone slots in through the top, and then the white cover slides over that, and then the lens magnetically attaches to the front. So it's a extremely accessible, but also discreet, simple design. It's going to come with a top strap as well as a chin strap. So for the folks that have disabilities, like I mentioned before, like cerebral palsy, where they might be moving around a lot, having a chin strap is super helpful that we found in our human factors. Lastly, we've designed it so that it's actually a social experience. So rather than traditional VR and AR, where it's all about the first person, our AR application that we've created for the mobile allows for dual display. So as the individual is composing sentences using our assistive communication app, they're seeing everything in stereo. But if they hit a play button to speak out loud the phrase they just composed, the whole screen goes black and it displays the type right reading for the person in front of them. So the person that they're communicating with sees it and hears it at the same time. So as you see here, so if they typed out the word hello and they hit play, it would actually say hello and show hello together. Internally, we have an iOS app called, it's a test suite that we have for ourselves, but we're willing to make it available for full controls of the BCI. So if you're interested in tinkering with it, you can turn channels on and off, you can adjust streaming sample rates, you can deal with sourcing metadata for tagging your data however you want, and whether you want to store the data locally or stream it out over to the phone or to a remote device. This is the last test suite. So these are our alpha units that we were doing a lot of human factors testing with individuals. There's been some advances in the software itself regarding accommodations about how the interface behaves with BCI. So someone with ALS relies on BCI versus someone with CP. The BCI plays a supporting role. So it's secondary as an access method. I'm going to kind of try and zip through here because I'm running out of time. But there's kind of a lot of cool stuff here I wanted to share with you guys. But the key takeaway is it's really it's not just it's not a read-only system. It's a write-read system. So thinking about being able to write to the brain and read the brain from multiple senses. And we built an application that takes advantage of that write-read paradigm that could be used for controlling an AR application. And then on the AR application, we can kind of do just about anything. So for instance, we've integrated Alexa. So we have an Alexa web service that we created at Cognixion that eliminates the dependency of having an Echo nearby. So you can use this whole system to control your smart home within the headset. So I'm going to kind of just skip along, but there's a lot of people that would benefit from this that are in the healthcare space. There's about 1.7 million people in the US alone that would benefit from this headset. We are focusing right now on, in 2021, we're filing for a 510K with the FDA, and we're going to be filing for CMS accreditation for medical reimbursement with Medicare. And so there's lots of funding available for that, and there's existing codes for it. So I'm going to kind of just zoom along. So that being said, I'll just wrap it up. But if you're interested to learn more, you can go to one.cognixion.com. You can connect with me on LinkedIn if you'd like. You can email me. Right now, there's a form on onecognixion.com that you can fill out and just express interest for your organization. If there's a university that might want it or a corporation that might want to have access to this. We are also looking at selling it as obviously a communication device for people with disabilities. But until we're covered by insurance, it would have to be an out-of-pocket expense. So that's it. Was that monologue like a fire hose or what? That was it.
Eden, you are muted. One day we'll all get the hang of Zoom, I'm sure.
Thank you very much, Nicole. Wonderful talk, Andreas. A lot of good questions in the chat, but I think we'll keep on trucking, given we're a little over time. I want to make sure we get in those other speakers. So we'll just go right into some networking sessions. I think we'll actually just cut that down to 1, and then we'll go into some giveaways. So Nicole, if you want to send us off to our rooms.